Good afternoon, everyone. Today we will explain Newton's method. We are behind, so I will go to Newton's method. Uh, Here you have, yes, let's continue. Here I announced that, okay, I announced a few days ago that here you have the mean value theorem videos. Okay, mean value theorem 1, mean value theorem 2. Okay, so please watch these videos, and if you have any questions, please send me. Okay, are you good with this? Again,
Professor,
yes.
when will our quizzes be for the recitation?
Mm, I will make a quiz soon. I will announce.
Yeah, can you please announce it, so we can prepare early?
Yes, and it will be
Okay,
easy.
thank
I will not make hard quizzes. I mean,
you. Okay.
and I want to tell you there is short video for mean value theorem and short video for Newton's method.
Yes.
They are for the quizzes. So I will send these videos when I make the quizzes, and the quizzes will be easy. Don't worry about them. Now,
Okay, thank you.
now we come. Now we'll explain Newton's method. Again, remember to watch these videos, okay? Part 1 and part 2. Good?
Okay.
Now let's start with the Newton's method. Newton's method is good method to solve equations. But before explaining Newton's method, let me ask you something here. For example, the quadratic equation x squared plus bx plus c equals 0, right? Do we have formula for this? To solve the quadratic, do we have formula?
Yes, quadratic formula.
Yeah. Yes, thank you. So the quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac over 2a, right? So we have formula. What about the cubics?
We do have one, but it's very long.
Exactly. We have one, and it's not just long, it's also useless. I will show you the formula. See, this one for the cubic. Would you like to use such formula? What do you think?
No, and you also have to evaluate cube root to.
Yes, that's another big problem. That's the reason it's useless. It's useless because, for example, if I give you easy cubic that has integer solutions, these cubic roots they are not clear. Sometimes you will have very complicated expression and you don't know that the answer is integer. So this formula is not that good. I tried to use it. Uh, I tried to use it 6 years ago, and it was useless. And I also studied the proof of this formula, but as I'm telling you, it's not good. So we don't have a good formula for cubic, right? Because this one is very complicated, and you will not know the solution easily. Even if you use calculator, these two cubic roots are very complicated, even if you use calculator. So it's not good. What about fourth degree formula? Do we have fourth degree formula?
Yes. It's even longer.
Yes. See here. This is the fourth degree formula. I didn't study this one. And I'm not interested in studying it. Because I know the cubic one is useless. So this one is also clearly useless, right? Now, the last question about this, about polynomials. Do you have formula for degree 5?
I don't think so.
We don't have. Fortunately, we don't have. If we have, it would be a problem like this, right? And it's proven that we don't have formula. It's not that we didn't discover it. I mean, they prove in math that we don't have. See here. Abel and Galois. Galois proved that you don't have formula for degree greater than or equal to 5. Anyway, so we have problems with solving polynomial equations, right? What can we do? We can use Newton's method. But we have problems not only with polynomials, we have problems also with equations in general. For example, if I ask you cosine x plus x squared equals e to x minus 1. Do you have formula for this? Clearly no, we don't have formula for this, right? So how can you solve this? You can use graphing, or you can use Newton's method, or you use another method. So sometimes you don't have formula, you don't have easy way to solve. So you study, for example, Newton's method and other methods to approximate solution. Now let's explain Newton's method, okay? Now okay, let's start. So here we have this graph, right? We have the function f of x. I want to solve the equation f of x equals r. Okay? Now f of x equals r, not r, 0. The equation f of x equals 0. From the graph, what's the solution? X equals what? Equals r, right? Good? This is the solution. But how to find the solution? By Newton's method. Here is the idea. First, you choose initial point x1 on the x-axis. x1, you need it to be close enough to r. Then you find the tangent line. The tangent line at x1. Okay? Then you find the x-intercept. You get x2, okay? Which x value is closer to r? What do you think? x1 or x2?
x2.
Now again,
x2.
yes, thank you. Now draw again the tangent line now for x2. You get x3. x3 is closer, right? Now,
Yes.
now tangent for x3, you get x4. Do you understand the idea of this method now? It's just like this. But clearly, we will not do, we will not graph the function then draw tangent lines. We will find the formula, right? Let's find the formula now. How to find the formula? First, find the equation of the tangent line at x1. Okay. What's the equation of the tangent line at x1? Y minus fx1 equals f prime x1 times x minus x1. This is the equation of the tangent line, right? Now, how to find x2, the x-intercept? How to find it? This is the x-intercept of the tangent line. How to find it? We substitute what? Y equals 0. Yes. Do you want to say something?
No, I just wanted to say what you said.
Ah, yes. So here, to find the x-intercept, we substitute y equals 0, because see here, as the x-axis, the y value is 0. And we know that the x-intercept is x2. So instead of x, put x2. Instead of y, put 0, okay? So you get y is 0, so minus fx1 equals f prime x1 x2 minus x1. I want to solve for x2. So divide both sides by f prime x1. But what should I assume before dividing? What do you think? Can I divide? I should say something before dividing, right?
It's not equal to 0.
Yes, thank you. So f prime x1 is not 0. So we assume this, then we divide now. We can divide. So minus fx1 over f prime x1 equals x2 minus x1. Now add x1 both sides, you get x2 equals x1 minus fx1 over f prime x1. So you understand now that this method will not work if the derivative is 0. So you need to remember this. Now, so we have this formula, x2 equals x1 minus fx1 over f prime x1. Now, exactly the same idea, you can find x3. When you find x3, you will get what? x3 equals x2 minus f of x2 over f prime x2. Again, you need the derivative to be non-zero at x2. Now, let's find x4. x4, same idea. x3 minus f of x3 over f prime x3. F prime x3 is not 0. Now in general, let's write the formula in general. You have xn plus 1 equals xn minus f of xn. I think, just 1 second. So f of xn over f prime xn. Good. So this is the formula. Do you have questions about this? Is it good? Please, if you have any questions, you can ask me. Now let's continue.
Professor, can you go back for a second?
Yes.
So why did we exactly do the fx1 over f prime x1 equals x2 minus x1?
Yes. I will tell you. Now I want to find the value of x equals r, right?
Yeah.
Let me show you here again. R is here, right? I want to estimate this value. First, I choose x value x1. Then I draw the tangent line. You see that the x-intercept x2 is closer to r than x1, right?
Yes.
So how to find x2? You find the tangent line, the equation of the tangent line. The equation of the tangent line at x1 is y minus fx1 equals f prime x1 times x minus x1, right?
Okay.
Now, how can you find the x-intercept, x2? I want the value x2. How to find it? You substitute y equals 0 in the equation of tangent line, and you substitute x2
How did we know that it's 0?
because it lies on the x-axis.
Okay.
So
Mm.
you get 0 minus fx1 minus fx1, right?
Yes.
Equals f prime x1 times x2 minus x1.
Mm.
Now I want to divide. But to divide, I need to know that the derivative is not 0. So assume it's not 0, okay? Then you divide.
Okay.
You
Mm.
get minus fx1 over f prime x1 equals x2 minus x1. Then add
Okay.
x1 both sides, you get the formula for x2. Now similarly, you can find now the equation of tangent at x2, and then you find x3, okay?
Mm.
How to find x3? Exactly the same steps. You will get x3 equals x2 minus fx2 over f prime x2. In general, you have this formula: xn plus
So
1 equals xn minus fxn over f prime xn. Yes.
you made it once x2 equals x1, and then x3 equals x2. But like, how can I know I should do both?
Yes, I will explain this when we solve the example.
Okay.
Because I will tell you how to find x1 and also how to know how many x's you need to find. I will tell you.
Okay,
Uh,
thank you.
yes. Now, about x1, we need it to be close enough to r. But now you may tell me, how can we know that it's close to r or not, even though we don't know r, right? The answer is, what do you think? How can you choose x1 close enough to r even if you don't know r? You studied something before that we can use. What do you think it is? At the end of chapter 2, we studied something that will help us finding x1. We studied the intermediate value theorem, right? For example, I want, here is the y value here is 0, right? Good. Here is, for example, say 4. Here minus 1, for example. Since this function is continuous, then we know that there is x value such that f call x equals r, f of r equals 0, right? So we know that, for example, 4 is here, right? And here say it's 5. This value is 5, for example. So we know that the solution will be between 5 and 0, the value of r. Don't worry about this now. I will explain it when we solve the example. But the idea that we will use the intermediate value theorem. Now, did you use the lockdown browser before?
Yes.
We I think we will use it for the quiz when we make a quiz.
Professor, when is our quiz though?
Uh, when I make it, because I was very busy recently, unfortunately. But I will make a quiz very soon. Don't worry.
Professor, by the way, we don't have Newton's method for this midterm.
Yes.
Yeah, I think it will be in the end semester.
Again.
I was saying that we don't have Newton method for the upcoming midterm.
Ah, yes, yes. Uh, Again, I will tell you something. I uploaded videos for the mean value theorem. These are included in your exam, okay? So you need to watch these two videos. Mean value theorem 1 and mean value theorem 2, okay? Today we are explaining Newton's method because we are behind. So we need to speed up. Now let's get back to Newton's method. Here you see the graph. It's better than my drawing. I mean, when I try to draw the tangent lines, here it's better. See here, you get closer to R. For example, see x4, it's very close to R. Now let's get back here. Now see here the form, and here you see this limit xn as n goes to infinity equals R. So these x values, they don't just approximate the answer. They converge to the answer when you take the limit. As n goes to infinity, you will get exactly R. Okay? Now, but the method will not always work. For example, see here. See this curve. You choose x1. Here you choose x1. You draw the tangent line, you get x2. See, x2 is not closer to R than x1. And now do the tangent line of x2. You go even out of the domain. So here I cannot draw a tangent for x3 to approximate R. So for some functions it will not work. But the idea is very nice here. And so that it's very nice to read from the book, because it explains it explains everything very well. See here. It tells you why the method will not work for some examples. I will explain it. So see here. For example, if I choose x1 equals 2, for example, and I want to find x2, okay? Assume you have function and we are starting with x1 equals 2, okay? Then x2 equals 2x1 minus fx1 over f prime x1, okay? But if the derivative is very close to 0, see what will happen. For example, if the derivative equals 0.01, then this becomes what? 1 over 0.01, 100, right? So this becomes 2 minus 100 fx1. And fx1, for example, if it's 1, then you get minus 198, right? So this is the idea. When the derivative is 0 or very close to 0, the method is not good. Don't worry about this. This is just for understanding. I mean, the examples that we will solve, they are good examples for the method. But the idea of this explanation here, that you know that this method will not work for all problems. How to fix this? You try to choose x1 to be closer to the solution. Then the method may work if you choose the x1 close enough to the solution. Now let's start with example 1. For this you need your calculator, okay? For example here, starting with x1 equals 2, find the third approximation x3 to the solution of the equation x cubed minus 2x minus 5 equals 0. We discussed before that we have a cubic formula, but it's very bad, right? I mean, it's complicated. But now see Newton's method how easy it is. But first let's name the function. It's f of x equals what? X cubed minus 2x minus 5. Good. Next, what do we need next? The question tells you find the third approximation. Okay? So this example is practice for the method. But in the next example I will explain how to choose x1, how many x's you need to find. I will explain it. Sometimes the example or question tells you how much to find. For example, find the third approximation. Now what is the derivative here? F prime of x equals what?
Three x squared minus 2.
3x squared minus 2. Thank you. Now first you write the formula. Xn plus 1 equals xn. When you solve, you need to solve like this, okay? You write the formula xn plus 1 equals xn minus f of xn over f prime xn. Then you substitute xn in the f and xn in the derivative. You get xn minus if you get xn cubed minus 2xn minus 5 over the derivative 3xn squared minus 2. Write x1 now. You get x1 equals 2, right? Now, when you want to find x2, you substitute in your calculator. I mean, don't keep saying x1 minus, then when you find x3 equals x2 minus, you don't keep writing the formula. Write it once like this, then apply, okay? So let's do it now. If you want, you can try with me to practice, I mean. So, but you need to be careful when you write to write parentheses, okay? So,
Assalamualaikum, Professor. Sorry, we were having construction in my house, so the Wi-Fi cut off. I just got it to work.
Walaikum salam wa barakatuh. No problem. Let's continue. So we have x1 equals 2. Now let's find x2. Yes. Now x1 equals 2, right? Now apply in the formula. See how I will apply here. You get 2 minus, I am applying this formula, okay? 2 minus, now open parentheses for the numerator, okay? You get what? 2 cubed minus 2 times 2 minus 5, close the parentheses, then you divide, open the parentheses, you get 3 times 2 squared minus 2, close the parentheses, and then find the final answer. It's 2.1, okay? So 2.1. Now when you want to find x3, you don't keep writing 2.1 in the formula. You don't keep writing this. If you are using your calculator, you use answer, okay? Answer minus answer cubed minus 2 times answer minus 5. Then when you want to find x4, same idea. You write answer minus answer cubed minus etc. Okay? Are you good with this? I mean, you no need to keep writing the whole number. You just use the answer. Okay? Me here, I will use what? I will use Control C and Control V. Okay? So let's see here. I have 2.1, Control C. Let's start again now. Control V minus, open parentheses, we have Control V cubed minus 2 times Control V minus 5, close the parentheses, divided by open parentheses 3 times 2.1 squared minus 2. Now close the parentheses, you get this number. And here write some digits. I mean, don't write just 2 or just 2.0 or 2.09. Write some digits. For example, write 4 or 6 digits. Do you have questions about this? Do you understand how to use this method?
Professor, I think so. You got the wrong answer.
What?
It should be, the answer should be 1.99 something.
This one?
Yeah, for x3.
This?
Yes.
2.1?
I got 1.99.
You get 1.9?
Yeah.
I think it's also in the book that it's 2.94. Let's see. Yes, it's 2.09.
Man made some mistake. My bad, sorry.
Did you forget parentheses while writing?
No, I did it separately because I couldn't save the last one.
No problem. Now let's solve the next example. Now this example is very much important. We will explain how to find x1, how to find the function, how to know the accuracy of your approximation, okay? So
Professor, this is, which chapter is this?
this section 4.8.
4.8.
Yes.
Okay, okay.
Now let's solve this example, example 2. Example 2 is very much important. If you understand example 2, then you are very good with this section, because this example you will have the whole idea about this section. You will find the function, you will find the value of x1, how to know what's the good initial value, how to know the accuracy of the solution. So let's see here. First you write like this: x equals 6th root of 2. So x equals 6th root of 2. Then you raise both sides to 6th power, okay? You get x to 6 equals 2. Subtract 2 both sides, you get x to 6 minus 2 equals 0. Then what's your function? F of x equals x to 6 minus 2, right? What's the derivative of this? 6x to 5, right? Now my goal here to find the solution for this equals 0, right? How to find the solution of this? I will tell you now. We will use, how to estimate x1 before starting Newton's method. How to estimate x1? Here you need what? You need to use the intermediate value theorem. Let me remind you about the intermediate value theorem. The intermediate value theorem tells you that let f be continuous in the closed interval AB, okay? And you have what? You have f of a less than n less than f of b. Then there is c belongs to AB such that f of c equals n, right? C between what and what? Between a and b, right? So you can have idea where is the solution. You can have the idea, how to choose x1 close enough to the solution by using this theorem, the intermediate value theorem. Now here I want to solve this equals 0. So in our problem n equals 0, okay? Let's do it here. So n equals 0. Now substitute f of 1. What's the value of f1? -1, right? Do you hear me?
Yes.
So f1 equals -1 less than n equals 0. Less than what? Less than f of 2. F of 2 equals 2 power 6 minus 2. You get 64 minus 2, 62. So n equals 0 lies between -1 and 62, right? And f is continuous because it's polynomial. So we know what? That the solution, there is r between what and what? Between 1 and 2, right? Between 1 and 2, such that f of r equals 0. So what would you like to choose x1? Let's have your idea. What's your opinion here? x1 equals what? What do you want to choose?
We can use 1. It's fine, right?
Yes, so 1 is perfect. So x1 equals 1. What about 2? You can choose 2, but 2 is not good enough. Because see here, which number is closer? The value at 1 or the value at 2? The value at 1 is -1. So the difference between 0 and -1 is just 1, right? But what's the difference between 0 and 62? 62. So 1 is the perfect choice, right? So thank you. You can choose 1.5 if you want. But 1 is easier, right? 1 is easier and closer to the solution. We know that 1 is closer. Now let's apply the method. Now okay. Now we will use Newton's method. Now I explained how to choose x1, right? Next step, write the formula. Xn plus 1 equals what? Equals xn minus fxn over f prime xn. Okay, so we have xn minus xn power 6 minus 2 xn power 6 minus 2 over 6xn power 5. Now let's try together to find the values, and I will explain how to know the accuracy. Okay? So x2 equals, no, where is the calculator? It's here. So let's start. You apply this formula, okay? You have 1 minus, open parentheses, you get 1 power 6 is 1. So 1 minus 2, close the parentheses, divide, open parentheses, 6 times 1 power 5, it's just 6. You get 1.16 repeating. Good? Now find x3. Again, you don't keep writing 1.166 each value you want to substitute. Me, I will use Control C, and you use this. When you click this answer in this button in your calculator, you will get this, and then you substitute it here. Are you good with this? Let's continue. So Control C. Then now x3, not x3, x2. I mean x2 minus, open parentheses, x2 power 6 minus 2, close parentheses, divide, open parentheses, 6 times x2 power 5. You get this number. Write 8 digits, okay? Because we need correct to 8 decimal places. Is it correct like this? Yes, it's good. Now, how to know which digits are correct? I will show you now. Look at x1. You have 1 here and you have 1 here. So 1 must be correct, right? Because each time the solution gets closer to, the x value gets closer to the value we want, okay? Next, look at x2 and x3. Here you have 1.1 and here you have 1.1. So you know that these are correct. What about 6? It's not correct because here it's 2. What about 2? We don't know yet whether it's correct or not. We need to find x4 to know about 2 whether it's correct or not. Next step, x4. If it stays 2, then it's correct. Okay? Let's find x4 now. Now x4 equals, now Control C, minus open parentheses control V power 6 minus 2 close parentheses divide by open parentheses 6 times control V power 5 close the parentheses. You get this number. Is it correct? 1.1 1.122 Good, it's correct. Now let's see the correct digits. Here you have 1.12, here you have 1.12. So these are correct, okay? What about this 2? We don't know yet. We need to find x5, okay? Let's find x5 now. Do you have questions about this? Now control C minus open parentheses control V power 6 minus 2 close the parentheses divide open parentheses 6 times control V power 5 close parentheses. You get this number. Now who wants to tell me what are the correct digits until now? What do you think? What are the correct digits?
1.1 maybe.
No, I told you you need to see the last two approximations. What are the common digits? So all these are correct. What about 9? It's not correct because here it's 6. What about 6? We are not sure yet. We need to find x6. In x6, if this 6 stays, then it's correct. If not, then it's not the correct digit, okay? Are you good with this? Let's find x6 now. Do you want to try to find x6 by yourself?
Professor, it's 1.12246204.
Yes, thank you. So, what are the correct digits now?
All except the last
5 and 4.
All these are correct, right? Here it tells you correct to 8 decimal places. To the right of the decimal point, okay? Here we still have 7. To the right of the decimal point we still have 7. So let's find x7 now. Can you find x7? I know x7 already, because the x7 will have exactly this. So I will write just this again. So 1.122462004. So these are the correct 8 digits. Do you have questions about this example? The book here approximated the answer. Here you must have 4. You have 4 in your calculator, but he approximated it to 5, okay? But I don't want to approximate. I want exactly the same digits as in the calculator, okay? So we needed x7. Now this example, cosine x equals x. We will not have enough time to solve the whole example, but we will explain some ideas again. There is another method to estimate the value of x1. You can draw the graph of cosine and and x. Okay, so y equals cosine. You can draw the graph of y equals cosine, and the graph of y equals x. Okay, then you can estimate the solution and choose your estimation as x1 and use Newton's method. Here you have 1 in for cosine, I mean. Then you go here pi over 2, and the other side similar. Okay, then you draw y equals x now. Let's draw it using another color. This y equals x. The other one y equals cosine x. Who wants to estimate the solution? Estimate. Remember, pi over 2 is what? Nearly 1.57. Nearly 1.57. So what's nearly the value of the solution for y equals cosine? I mean cosine x equals x. What do you think?
1.35.
1.35. Good. But there is better. Maybe my drawing is not good enough, so you choose 1.35. 1 is better than 1.35 because 1 is closer to the solution. But I think my drawing is not clear. So, but we will choose 1, okay? But 1.35, you can also choose 1.35 as you like, because there is no one value for x1. You can choose 1 or 1.35. The idea you need to choose it close enough to the solution, okay? So you can choose 1.35 or 1. Me, I prefer 1 because 1 is integer and easier. But 1.35 is correct. As you like, you can choose it. Now, do you like this method to estimate the solution? I mean the value of x1. So here you can choose x1 equals 1 or 1.35 using the graphing, and then apply Newton's method. Applying Newton's method for this example, we will do it next time. But here I will explain just how to find x1 for this example. But what's the other method to estimate the value of x1? What do you think? Don't you remember what we did a few minutes ago? We used what?
Using Newton-Raphson?
No, yes, we are solving using Newton's, but I mean how to estimate x1. A few minutes ago we used intermediate value theorem, right? Intermediate value theorem, right? So here, what's our function? Subtract cosine x both sides, you get x minus cosine x equals 0, right? So the function is f of x equals x minus cosine x. Are you good with this? Next, I want this to be 0, right? And we know that this function is continuous. So I need to find x value that is less than 0 and x value that is greater than 0. Then we know that there is solution and it's between these x values. Now here, if you substitute 0, what's the value of f of 0? Minus 1, right?
Minus 1.
Here, if you choose 1, for example, you get 1 minus cosine 1, right? Cosine 1 is positive and not 0, right? Positive, not 0, and less than 1. So it will be greater than 0, right? So we know that the solution will be between 0 and 1. Good? If you don't want to choose 1, as you like, you can choose pi over 2, for example. No, not pi over 2. You can choose pi over 4. Pi over 4 is perfect for this. What's the value at pi over 4? Pi over 4 minus cosine pi over 4. You get nearly the value of pi over 4 what? 0.78 for 0.785 for pi over 4, nearly. Minus cosine pi over 4, 1 over square root of 2. 1 over square root of 2 is nearly 0.7. You get positive answer, right? But this is very No, not 0.85, 0.085. So you know what now? That the solution is very close to 0.085, right? Are you good with this? So the solution will be between 0 and 1 or 0. We will explain it again next time. Do you have questions? Did you all write your names, student ID? Okay, I will take names and you can leave if you want, and have a nice day. Was it clear? Did you understand the Newton's method?
Yes, Professor, it's clear.
Yeah, thank you.
Have a nice week, Professor.
Thank you. You too.
Yeah.
Yes, we are done like this.